Is it on now? Excellent. Well, we're going to go ahead and get started. This is the Network Time Protocols Working Group. I know we're a bit time zone challenged, so we are missing a number of our regular remote participants. So I guess they will be catching up online afterwards. As a reminder, for those of you, you are an official IETF working group. This is the note well that you agreed to when you registered for this meeting. This has all of the rules by which the IETF operates and the processes. If you have any questions, feel free to ask Dieter or I or our responsible AD, Eric. Couple other things. Dieter has agreed to, Dieter is online today. He's agreed to work on the notes. The notes page is linked from Data Tracker, so anybody can contribute and assist him as well. So feel free to put notes there. The other thing, since we are 2 days in, I'm assuming most people know this by now, but please scan the QR code to register for to note your attendance in this meeting, and use that for entering the queue to speak. I don't imagine queue management will be difficult with such a small group, but we still need to use the tool. Excuse me. So with that, those are our admin details for today. This is our draft agenda. We have just covered the administrative and agenda bashing. We'll do a quick review of documents. We have a remote presentation from Jason on the GNS Tesla issue that he brought to the mailing list. And then we have a number of other updates on ongoing efforts. So with that, is there any agenda bashing? Nope. Okay. So the document status and review update. We are pretty much where we were last time, with the exception that we have requested publication for Kronos. The interleave modes is being deferred to NTP-v5. The updated registries, and why did that end up in there twice? In any event, the registries document is with the AD, the enterprise profile document is with me, and Kronos has just recently publication has been requested. So those are the documents that are beyond the working group and in the publication channel. So the next thing on the agenda is Jason. Are you ready to go, Jason?
Can you hear me?
Yes, we can.
All right, so let's see. I'm going to try and share my screen. Is it working?
So far, we're only seeing you.
Okay. Looks like I've put in a request to share the screen.
I don't see a request to share the screen yet, so perhaps you could try again. Oh, there we go. And I will grant you that. Such power.
All right, can people see my first slide?
Yes, we can.
All right, I'm ready to begin. All right, my name is Jason Anderson. I'm a PhD student at Stanford University GPS Lab, and thank you for taking the time to allow me to speak to you all today. And This title of the presentation is Addressing GNSS Tesla Synchronization Vulnerability. So starting out with GNSS, GNSS is GPS, except it's broader. There's multiple constellations now. We have Europe, we have China, we have multiple systems now. GNSS is a broad category, and all GNSS signals are one-way. So that means it's not possible to secure against a delayed signal without a non-GNSS two-way sync. The reason for that is if you imagine if we start with our GPS satellite, hopefully you can see my cursor. If we submit a signal and there's an adversary in the middle of that signal, this could be a basic repeater, just literally listen and broadcast. The receiver will perceive that the clock is lagging. So we have a one-way signal. There's no way for me to get around this. The only way to do this is with an out-of-band, a two-way signal. And if I have that signal, then I can certify that my delay is bounded based off of that network traffic. And the current state of the art for GNSS authentication uses an algorithm called TESLA, which stands for Time Efficient Stream Loss Tolerant Authentication. The reason why we have to use this algorithm is because GNSS signals generally have extremely low bandwidth. We're talking 50 bits per second. So the way that TESLA works is it's constructed in a specific cadence where we send messages, we submit a commit of those messages, and then we distribute a key later. Okay, so message, commitment, key, message, commitment, key. And the delay is what allows us to provide that authentication because the construction of these keys are in a specific way we can provide cryptographic authenticity. In my paper work, I labeled this delay capital theta, the key release delay. So this is the time from this commitment to the release of the key. I have colors on here to demonstrate that. So the typical delay that we're talking about here is it depends on the GNSS system. Galileo is Europe's answer to GPS, and Chimera is a future GPS concept that's in the works in the next couple of years to authenticate the signal. So on that, the key release delay will be 30 seconds to 2 minutes or 2 to 6 seconds, depending on your system mode. I specifically work on SBAS. SBAS is the constellation that ensures that aircraft are notified within 6 seconds of GPS failure. So we have listening stations throughout the continent that are listening to the GPS signal. If there's ever an issue, they're immediately notified via this constellation within 6 seconds. In all of my diagrams, I go from left to right for increasing time of release, meaning I should have started with this with the messages and yeah. So here's the problem with clock lag. So when we have a TESLA system, once the key is made public, people can make forged messages. So in order for TESLA to be secure, we need to provide a bound on the clock offset. So on screen, I have my normal message cadence. And then here is a delayed message cadence. So we have an adversary that's delaying the signal. If they're able to delay the signal more than capital theta, then they can listen for the key and then forge messages. So this diagram reads left to right an increasing time of release. So my receiver is perceiving time in a delayed state, so far delayed that the key has been released, the adversary uses the key to generate the messages, and now we have a forged signal. This happens if my clock offset, lowercase theta, is less than negative big theta. So if my receiver clock were 7 seconds behind for the SBAS system, then my receiver would accept forgeries. So why do we have this vulnerability? So in the original TESLA scheme, there is a bootstrap procedure where the key release delay is set individually by provider and receiver. So TESLA is an Internet of Things protocol. Okay, two providers and receivers can decide this key release delay. And if an adversary interferes with that bootstrap, then the key release delay increases. So in effect, a denial of service is possible, forgery is not. But with GPS TESLA, the key release delay has to be system-wide in a multicast context. So we can't have individual settings. Everybody has to have a clock that's within a specific offset. Individual clocks also have stochastic drifts, And knowledge of that insecure clock would reveal whether or not the receiver will accept forgery. So if my clock spontaneously goes to an offset of more than 7 seconds or more than 6 seconds, and somebody knows about it, then I know that that specific receiver will accept forgeries. And in my paper, I show that there's a simple test to find insecure outliers. Very, very simple. I will go really quickly through the slide, but essentially if I'm using my basic NTP protocol and I'm intercepting that NTP message in the clear, I can just measure the receipt time using the T1 inside the timestamp. I can infer whether or not a specific clock is delayed with high probability. And so these equations just describe that test. But if I can listen to the traffic and the T1 inside NTP is in the clear, then I should be able to find those outliers. So, so here's the vision of the future of why this is important. So when we have autonomous cars and autonomous aircraft, soon we're going to have Tesla-enabled GNSS authentication, and requirements are going to come in to say you need to have an authentic signal for your safety of line application. So if you're driving an autonomous car, you better be authenticating your GPS signal. So each of those vehicles are going to need to speak with a time server to certify that delay bound that I was talking about before, and we can have an adversary that's affecting man-in-the-middle times. Aircraft, the context for aircraft is that receiver manufacturers for aircraft do not want an internet connection. So what that's going to look like is we'll have a nice clock on the aircraft, and then through periodic maintenance, we'll do synchronization. But for autonomous vehicles, I anticipate that the autonomous vehicle can just synchronize whenever it wants. So for an attacker, the attacker only needs to wait and find a bad vehicle. So if I might not particularly care about which specific vehicle is bad, but if once I find a vehicle, I can drive it off the road. This type of spoofing is actually now recurrent in warfare now, and it's actually been demonstrated that we can cause a Tesla to go off to the wrong exit. Anyway. So previous research considers estimating clock balance. This is a figure from one of those plots. So if we have conservative estimates of what a clock will look like over time between aircraft maintenance, we can expand this. So this is I start with synchronization, and this is my bound over time, and then this would be the time when I need to resynchronize. But from my perspective, for aircraft specifically, they go through large temperature changes. So my professor would say that a clock makes a better thermometer than an actual clock, which he's joking, but the point is that airplanes also experience radiation. There's going to be a stochastic element of this. We're going to have outliers, and now there's a test to see if I can find this specific outlier. There's a very easy test for me to find those outliers. So how do we address this, and why am I here addressing the standards body? Well, so there's a very simple fix to this, and that's just to not reveal T1 inside the NTP protocol and make non-predictable queries. There's already an existing NTP data minimization draft that I think that would be a good idea. Now on the email list from before, I received the suggestion. Well, why don't we just make this is a receiver problem. They need to make sure that their round trip time on their synchronization is short, or they shouldn't go. Well, I want you to imagine yourself on an airplane, and the GPS receiver has gone bust, and so they need to take 30 minutes, delay your flight, and replace the receiver. But now the server is busy or not working. Then we'll have an issue where we cannot fly. If we have this requirement right here, we cannot fly if there's something goes wrong, and this requirement is likely not palatable to current aviation stakeholders. So this is why I think that the data minimization idea is probably the best way to go, because it's going to be, there's a lot of stakeholders to convince here. So how do we communicate this security requirement that I'm talking about here? So I'm working with at least 5 different parties in here. I've got Europe, I've got the United States, I've got private industry, and I'll tell you, Tesla timing synchronization is always their afterthought. So if right now each of them is going to have to create their own standard, and I'm working with them, but you can imagine dealing with government, et cetera, it's very hard for them for me to communicate with this and for them to put this on their priority list, which is why I think the best way to do would be to, instead of having each of them manage their own requirement, we should cite them to a single standard. I've used code that is compliant with requests for the standards that you all have. So if the standard were incorporated, then maybe someone would implement a standard mode, and then everybody is using the same standard, and we wouldn't have implementation errors all over the place. So my final thoughts here is I'm hoping to get support from you all to incorporate these ideas into NTP so I can cite one standard in future stakeholders, especially if speaking with all of these stakeholders. If I can cite another standard, then it's much more believable that they'll listen to me. Amongst the aviation receiver manufacturers, Boeing, Airbus, autonomous cars regulators, and the navigation systems themselves. So I understand that was fast. I'm happy to go back, and I'd like to acknowledge the sponsorship on this work, which would be the Federal Aviation Administration. So thank you.
Okay. Let's start with any questions on the content. I remind everybody to get in the queue. Go ahead, David.
Yes, I was wondering, to what extent is this already covered by the suggestions made in RFC 8633? Because I think that the not leaking T1 is a fairly well-known measure already against information leakage on the current clock. Well known enough that when we started at my company building a new NTP implementation, this was just like one of the first things on our radar in terms of, yeah, the standard says one thing here, but you really should do another. Is 8633 enough for this purpose, or is there missing something there?
I don't know the number offhand, but I recall that the data minimization was a draft. So I think resurrecting that draft would be fine. But let me look at this number. You said 8633?
Yes.
Oh, that's the NTP BCP. David, I don't remember if, well, I don't think data minimization was in there, but are there parts of it you think would not require the development of that draft?
I'd like to say one more thing there. So I'm looking through this. I do think that there are parts in here that cover this. Looking at the data minimization draft and the NTS draft, the concern here was privacy with these data information leakage. My concern is acceptance of forgeries, which I think is requires its own language. Because if I have an implementer who is not concerned with privacy, who cares, right? But this isn't about privacy. This is about acceptance of forgeries. So all in all, yeah, maybe this could be a one paragraph change somewhere, but yeah.
Are you willing to work on? Are you willing to contribute some text? Like, can you write up what you think is needed and send that to the working group?
Absolutely.
Go ahead, David.
I have one secondary question, and that is, we seem to be heading this direction anyway in blocking this leak with NTP-v5, with not providing transmit timestamps anymore. To what extent can this wait till NTP-v5, or is the timeline for this critical enough that we need to move faster?
What's the timeline for NTP-5?
Well, that would be a good question.
I
think NTP-v4 is going to be around for a while.
So the FAA's sort of soft goal is to have SFAS authentication by 2024. So so I'm working with, I'm going to still be communicating with them anyway, but I don't think that someone's going to die if this isn't critical, right? But yeah, so I would like this incorporated into the standards within 2 to 3 years. That would, idea, but it certainly help with my with me talking to regulators now if it were incorporated in the next draft. So yeah.
David?
Just because I wasn't around back then, the data minimization draft, you were stating that this would mostly cover it. It seems to be stuck in a state that suggests that it was very close to being published, and I'm wondering what the reason was it was abandoned.
I don't remember the exact reason why that one wasn't finished. I think there was some opposition to it, and we never got it resolved. One of the challenges of the IETF is because it's contribution driven. If somebody sort of runs out of steam working on something, sometimes it can die on the vine. So let's see. Yeah, it could be that we could just resurrect it and get it through much more quickly. Perhaps that's a starting point for you, Jason, if you wanted to give that a shot. I think the key right now is we would need a draft that people could comment on.
All right, this is a very new process for
Yeah,
me,
just
but I
looking at
am happy to take a stab at it.
Yeah, especially if you wanted to contact the 2 existing authors. Oh, yeah.
Eric, I was just going
I think
to say just that. You can reach out to the 2 authors. They're still on the list, I think.
Yeah. So
you could also CC NTP-chairs and NTP-ADs if you want as well.
Yeah. I don't. Yeah, I think this was just something that we never managed to finish. I don't think it was hugely controversial at the time. It was a. I'm trying to put the state back in my head as to where we were with it. Yeah, I would say contact the authors, see if you guys can come up with a draft. I do think it's worth, if you want it in, I think it's going to be a while before NTPv5 is deployed to the level. So I don't know that you necessarily want to wait for that. I think we still have some maintenance of NTPv4 to do. Marcus, are you in the queue? Would you like to? Or I guess Eric. Well.
I'll just stand on my toes here.
You can tip it down. There you go.
This works. Yeah, I figured I should say something since I think I'm the only NTS author present here. I saw Dieter on the
Dieter's online, but
online as well. And we, together with Jason, we've had some discussion about this off list, and I think we sort of agreed that there's nothing wrong with the NTS standard per se. Though I'm maybe a bit biased as a co-author. And that's mostly because we set up a number of security requirements early on in the document, and what Jason is presenting here isn't among the requirements, so it's sort of a technicality there. And this, like, the big new thing here is that the idea of sending client time in clear text hasn't been considered harmless before, and as Jason has shown, there's definitely potential harm to that. And like we also agreed, the authors that discussed this with Jason, that going forward with the NTP client data minimization draft is probably the best way to address this. I just looked it up. It's Daniel Franke and Anshel Malhotra who are the authors of it. Daniel's been active in the discussions with Jason, so I think he said that he's very positive to resurrecting the draft. We could try and get hold of Anshel as well. I think she's sort of changed employment since she was very active here, so her email may not, or sorry, her IETF registered email may not be working, so we could try and hunt her down. What more did I have in my notes here? Oh yeah, so the NTS draft already sort of refers to the data minimization. Sorry, the NTS RFC already refers to the data minimization draft, and specifically says that recommends using what's in there in order to protect against things NTS isn't protecting against. And that's it for now.
Okay, thank you, Marcus. I think we have a way ahead, and Jason, if it would be, I think it's sort of back in your camp if you want to get this moving again. I think there's probably.
Oh yeah, I'm happy to take the action item of recontacting the authors and drafting language. I'm just trying to meet you all because this is definitely outside my
Outside your
my GPS niche. So I'm very happy that
well,
people seem supportive.
all right. Well, if you need any help as a newcomer to the working group, Did or I are more than welcome, are more than happy to provide pointers. So, all right.
Is Eric Eric want to?
Oh yeah, I'm sorry, Eric. You're in the queue.
Oh, that's okay. If you wanted to move on, that was going to be fine. My only question was, are you saying that data minimization is sufficient, or is there extra stuff, the extra work that will be required?
There is one other thing that I would consider. So if we have a vehicle that is sending repeated synchronization requests at the top of the second, that also will reveal information about the clock on board. So my suggestion is data minimization by removing the original timestamp, but also making sure that your queries aren't on an obviously periodic basis. And I'm kind of up in the air about whether or not that is like a strict requirement.
I'm wondering where you might want to say that, either try to shoehorn it into minimization as the document is revived, or if it belongs somewhere else. I have no useful thoughts on the matter. I'm just curious if it was necessary, insufficient, sufficient, whatever.
I think that those two conditions will be sufficient. Thank you for the question.
Okay. Well, then I suppose, yeah, maybe see if you can put it into the minimization doc. Worst case, it gets taken out.
Thank you all for your questions and engagement. I appreciate the time, and I have some action items, and I'll follow up hopefully before the San Francisco version of this meeting.
Okay, that'd be great. I am looking. I just took a quick look at the closed captioning, and I think it's kind of amusing that the minimization draft is actually the immunization document. Yeah. And so that's an interesting one. So anyway, on that note, the next thing on our agenda is NTP, NTP v5. The first part of that is the use cases and requirements document. That document has been pretty stable. There's been some recent traffic on the mailing list. I know James has notified us that he wasn't going to be available for this meeting, and but I think this document is getting pretty close to being ready for working group last call. At the very least, to get folks to comment on it. And so I wasn't going to go over it in any more detail today, unless anybody had any questions or comments on it. No. The next document is the NTP v5 specification. I know Miroslav is online. Do you want to speak to the status of that document, Miroslav?
Yeah, just a quick update. There was some editorial changes, and there were 2 technical changes, and that's the version field, the server information that was changed from using a minimum and maximum supported NTP version to a bit field. So any combination of supported versions can be described in this extension field. I don't expect like implementations that would skip some NTP versions, but maybe it will be useful. And the other technical change was the extension field which provided the offset between 2 timescales that the client can request, and that was changed to a more general concept using secondary receive timestamps. So the client can request an additional receive timestamp and calculate the difference between any 2 timescales supported by the server. It can actually request more than 1 secondary receive timestamp. And as David suggested, this field includes the error number, so it's possible to get offsets larger than the 138 years maximum of the 32-bit second field. Yeah. And I think that's all technical changes that were made in the new version.
Okay. David?
Yeah, so you were skating over it quite quickly with the requirements document, but I wanted to comment on that I think we should not be moving to a last call just yet. And I think we should do the 2 consensus calls suggested by James before that point, especially on the mode 125 issue, because I think that's going to be real nasty in the last call if we try to do that through a last call.
That's a really good point, David. You're right. We should do those 2 consensus calls first.
And then I have a further question for Miroslav, and that is, do you have any updates on other implementations of the NTP-v5 current draft? Are there just the tech demo you made and the current work in NTP-DRS, or is there more at this time?
Those are the only 2 I know. I updated the one I wrote to follow the current draft. Not sure if you updated yours. We can try to interoperate.
We haven't updated ours in a while. It's been a bit hectic around a few other projects. So my goal is to, in the coming 3 to 6 months, make another iteration on the latest draft and then see where we go from there.
Okay. Are there any other questions on the NTP-v5 work? The next IETF meeting will be in San Francisco. We will try again to see if there's any critical mass to do any sort of hackathon effort around NTP-v5 at that time. But with that, thank you very much, Miroslav. The next version that you upload, we need to, we can switch it over to a working group document because I know we've switched the data tracker so that it can be done. All right, so with that, the next thing on the agenda is NTS. This piece has 2 pieces. The first, we have a little bit of a deployment update from Krister and NetNode. So, and I need to let you grant your screen permissions. So Krister presented this at the IEPG on Sunday morning as well. So here we go.
So hopefully this works this time. So my name is Krister Weinigel. I work for NetNode, and we've been involved with NTS, the standardization, and one thing NetNode have been doing is to set up our own NTS servers, and we're sort of committed to running an NTS service. So this map is, well, shows basically our deployment. So the two servers in Stockholm, or the two dots in Stockholm, they are actually my clients talking to our servers in Stockholm, and our servers are located in the same place, basically. The two white dots in the States, they are my clients doing testing. And this is basically a year ago when we started up our, well, we had prototype servers, and these are the sort of production servers we have in a couple of computer centers in Stockholm. And, well, this is going to be the most boring move in the world, so let's speed it up a bit. So this is usage, 1,000 clients per hour, 2,000 clients per request per hour, so not really that much at all. And it looked like this for quite a few months. So what NetNode has done is we have our own NTS KE server, and these are the requests to the KE servers. And then we run timestamping in an FPGA, but that's not too interesting. So anyway, nothing really happened for 8 months. And then coincidentally, I believe, IETF in London was started on the 7th of November. And now we're at the end of October, and this is where things start happening. So if you notice numbers, they start going up a bit. So 2,000, then we're up to maybe 5,000 hits, 7,000 hits. And yeah, this is when the hackathon in London starts. And on the 7th of November, we got 10,000 hits per hour. 10,000 is really nothing. It's only a few queries per second. And then a week later, we're up to 100,000. So I don't really know what is happening here, but somebody has been starting to use NTS. And kind of funny is that you can see sort of how the usage of NTS actually follows the daylight cycle. So when it's brightest in an area, that's 12 o'clock noon in that area. So this was quite fun. We didn't have a problem handling this. We had one machine running NTS KE, and it could handle this just fine. So we didn't do very much. I added a bit of threading to the code, so it was supposed to scale up rather decently, and it worked rather well. And it just kept increasing. The traffic just kept increasing. And funnily enough, I have no clue who these people are. Nobody has been talked to me. Nobody has asked NetNode, can we use your service? They just started using our servers. And, well, even more. So mid-November, Christmas comes, I go on Christmas vacation, and we're doing good. And it just keeps increasing and increasing and increasing. And, well, there's not much to say. I mean, this is rather tech light. This isn't tech heavy. It's just sort of, I kind of like this because, well, I work for NetNode. We've put up a service, and for me personally, this is the first time ever that anything I've made becomes this big, that people are starting to use stuff that I've made. So New Year, I get back from Christmas vacation, and now we're starting to get into trouble because the poor machine we're running the servers on, it's in the Linux kernel, started complaining about running out of memory, running out of sockets. We're probably under a DDoS attack, and yeah, it looked like it. So we moved to a bigger virtual machine, added more CPU, added more memory, and then we started having problems because our server is actually running as a Docker container, and it turned out that the logging from the Docker container is single-threaded. And this single thread for the logging is starting to become a bottleneck. So we had to do, or rather not me, our poor operations team had to scramble a bit, set up load balancing. So we set up 2 NTSK servers and added a load balancer on the IP level in front of it. And it, well, as you can see, the traffic kept on increasing. So at the end of January, we're up to about 2 million hits per hour. So that's a 1,000, 2,000-fold increase in about 3 months. So quite fun. Here's a timeline if you are watching this afterwards or want to see the figures. One interesting thing is that, well, we had about, if I look at the traffic over a day, we had probably about 5 million unique IP addresses. 20% of those were IPv6, so they probably overlap with the IP4 addresses. But we have at least 5 million unique clients per day. And if anybody feels guilty, knows that they're behind this, please tell me, because I'd like to talk to you. Not because I'm mad or something, it's just I'm really curious to see how well do our servers perform. Do they have any issues? Can we do things better? Because I'm curious. So thanks for listening. Any questions, by the way?
Oh yeah. Does anybody have any questions? Go ahead, Miroslav.
Yeah, I'm wondering, have you looked at some statistics? How many requests per IP address are there? Like, is there a relatively small number of clients making requests at a high rate? Like, I don't know.
Most of them are making sort of 1 or 2 requests. So, I mean, something like, I'd say something like 99% are making 1 request. A few IP addresses are coming back, but it might be multiple units behind a NAT firewall. It might also be sort of, they might have issues that, well, traffic won't reach us and they might sort of try again. But 99% of them make 1 or 2 requests.
So how many unique addresses, roughly how many users do you think you've had?
I don't know. 5 million. I saw about 5 million unique IP addresses over 1 day. And when I tried to see sort of how often do the same IP address come back, I think it was a few days in between. So if that sort of scales, I'd say 5, 10, 20 million unique devices probably. But it's hard to tell. We've tried to identify the devices, do Nmap, see if there's any pattern to where they come from, and basically it's all over the world, and I don't know. It's hard to say.
All right, thank you. Did you have something else, Miroslav?
No, that sounds to me like there is no abuse, like a wrong implementation, something.
Yeah, it's correct NTS. There are correct requests. They use the ALP and the way they should. They send properly formatted NTSK requests. So I do not believe this is a port scanning or a denial of service tag. I actually believe that these are real users.
Actual users of NTS.
Yeah.
Okay.
Yeah. And they are caching the cookies, right? Like they are.
I hope so, but I'm not sure, because one thing, we actually had one issue that we didn't respond to timestamping requests because they were adding padding to a field that we didn't expect them to add padding to, and we were quite strict in the FPGA implementation. So I actually had to loosen one of our checks to be a bit more lenient. So I do not believe it's one of the normal, I don't believe it's Cronin or NTPsec that is the client. It's probably a custom client. And it might be that that client might actually do sort of a KE request, a timestamping request, and then forget all about it and then do it again. But that's just my suspicion, but I don't know.
Yeah, I think we're interested to figure out.
Yeah,
we'd love to hear from the implementer, the people that have put this in whatever devices they've put it in. David?
Yeah, I was just wondering, you were mentioning these slightly malformed requests. Did they occur a lot or a little? Because we might have sent a few in the development process of our implementation.
All of them. It's sort of 1% of traffic, or 99% of traffic seems to come from one client, and it does this thing. And then we have sort of a few percent that are sending requests the way we expected them to be.
Okay.
So it seems to be
my next question also moved.
Yeah, so one manufacturer probably put this in as a default in their devices, and they've started rolling it out in October last year, and they've been just sort of rolling it out to more and more machines as time goes by. And it's actually peter off now, so we're at about 2 million requests per hour now. And that's not very much. I mean, that's 500 requests per second. It's not really that much. If it's not sort of Amazon size, but it's still, I mean, personally, I'm really happy that somebody likes NTS and is using it, and I feel, hey, I made a small bit of difference to the security on the internet.
All right. Thank you.
Thanks.
So the next one is Martin Langer is going to talk about NTS for PTP, what his current plans are.
Yes, I can my screen. So
It's coming.
Hope it worked.
Yeah, I can see it.
Perfect.
Thank you.
Okay. So yeah, regarding the NTS for PTP protocol, not much has changed yet. So I will keep it short here. At this point, a small overview what NTS for PTP is about. The goal of NTS for PTP is the realization of security measurements for PTP 2.1. And we have two communication modes to be distinguished. We have different ways to be secured. So the first one is PTP multicast and mixed multicast unicast connections. Here we use a symmetric group key. Technically, we can use Tesla-based key exchange, but it's more complex, so therefore we use a group key in the current NTS design. And the second mode involves negotiated unicast connections. For this draft aims for secured end-to-end connections. The basic idea is we use NTS to support NTP and PTP. So we have to extend the NTS protocol accordingly for PTP support. So this is the basic idea. As already said, not much has happened in the last year. The draft was updated, but we have no many changes. There were several reasons for this, such as I'm writing my doctoral thesis, discussion about the draft merge with NTS for UPTP, have a job change, and I supervise a current small proof of concept implementation of NTS for PTP. NTS for UPTP, this was the unicast only approach from Meinberg. Currently, I guess they work on something else. I forgot the name. So NTS for UPTP is currently dead, but I try to merge some of its content in my own draft document. As of this month, I work on NTS for PTP. I started again on NTS for PTP, and I currently consolidating all the documents, mails, and feedbacks to push the content or to go further. And yeah, what is the next step? Yeah, I know nobody has time to read 70 pages of a draft document, and therefore I plan to prepare two documents for the NTP working group. The first one is a too long didn't read version of NTS for PTP. It should describe in 2 pages or less what NTS for PTP is, how it works, what core feature it provides, and what design decisions have been made. And the features and design decisions then refer to a section of a second document. And the second document contains much more details, describes alternative solutions, and contain a small voting section. So everyone who wants to can easily give their opinion or suggestions. So this is idea. these documents. And on this, I try to update my NTS for PTP draft, and hopefully I can push it to the NTP working group. So yeah, this is basically the current state of the progress.
Okay, on the go ahead, David.
Yeah, I had one question. Were you planning to also state the security goals and assumptions in the requirements document? Because I was reading the draft just before this meeting to get a bit of a sense for this topic, and I was noticing that I'm missing a lot of context around what exactly the security model here is, what it's trying to achieve, and what assumptions are being made on the PTP side of things.
Yeah, this is very complex in PTP. We have different aspects. So we have different communication modes. We have, as I said, multicast and unicast communications. We need different security solutions to cover that. And also we need to define the communication between the NTS key server and the time server side. In NTS for NTP, this is implementation dependent, but it doesn't work if we use unicast communication PTP. So we have to define that. The current draft document is, yeah, we need updates. There are many changes. Currently, I don't put the changes into the draft document because I have feedback and mails, and I have to filter them to see what must be changed, and because of that the draft is very complex or pretty big, currently about 70 pages. I want to write these documents to make it easier for you to see what's going on in this protocol. How does it work? So this is the reason for the too long didn't win version. So maybe 1-2 pages, and I guess it makes easier to discuss in content. So yeah.
Okay. Well, I guess at this stage, welcome back to the NTS for PTP work, and we will look forward to your contributions. Thank you very much. So the next thing on the agenda is the NTP over PTP. I know there's been virtually no changes on this. Miroslav, did you have anything you wanted to say?
There was just one change in the document since the last version, and that is sequence ID is now required to be incremented in order to not break some hardware or drivers that might be looking into this field and maybe assigning timestamps to it. And previously, it was always set to 0, so this could be an issue with some hardware. I haven't seen it yet, but it might be, I think.
Okay. This document seems to have been around for quite a go ahead, Martin.
Okay. Thanks, Miroslav. I read your document, and I guess it is pretty good now. As I said, or I write in the email, maybe we need a bit more clarification that we don't need a working PTP. So you use the PTP frames to transmit NTP. And I guess it's a small change. So this is such only a suggestion. So maybe, yeah, it's just an idea to improve the document.
Thank you for that. Yeah, I will try to make it more clear.
Okay. If you could make that update and then resubmit it as a working group document, that would be great. Thank you.
Okay, thanks.
So the next thing on the agenda is the rough time document. This one we haven't had much action on in a while. I don't know if I'm gonna on the queue. So we're going to hear from Marcus. Go ahead. You can come up here if you'd like, because you're the author speaking to it anyway.
Yeah. So as most of you probably noticed, not much work has been done, at least visibly. Both me and Watson, who are sort of the two people who are currently working on the draft, have been busy with other things. As far as I understand, Watson will have some more time going forward, and I'm trying to make time. So, but we definitely have intent to publish new drafts with changes. The current draft, I think, expires in 2 days, and my goal is definitely to get at least something done before then. So a couple of questions we haven't really addressed yet is all the very good feedback we got from the Google people, who where Watson has made some issues on the GitHub repo that we're sort of trying to get into text. Let's see what else. I know Martin, I think yesterday, or at least yesterday, sent a couple of really good comments on the text. So thank you very much for those. So a couple of issues I would love to get comments on right now is multiple people have asked about the message format, and that includes Martin's comments yesterday, asking, why don't we do tag length values or this or that. And also what Martin brought up is that currently Roughtime does not use network byte order. And the answer to that has always been, it's always been that way since the standard was sort of the first draft was written. And what I'm really asking for comments here is, is it too late? Would it work? Because what we've seen is that the implementers are pretty slow when it comes to updating according to the drafts. There are a lot of servers out there that are actually running Roughtime versions, pre-draft 0 even. And finally, I'll say something on the hackathon as well. For the last IETF, I tried getting a hackathon together. Turned out I was the only participant, so not much of a hackathon. And I spoke to Christer, and we're both interested in doing a proper hackathon at some point. And we agreed it's probably going to be easier to do either when in an IETF in Europe or one in the United States, or sort of the Americas, where the time zones are suitable to the people who we think are interested. So that's sort of the key points I have for now.
Okay. Does anybody have any questions for Marcus on the Roughtime work? No? All right, so we will look forward to the updated draft. Thank you to the folks who've put in comments so far, and people can continue to comment on them. At that point, we are at time. It is 5:59. Are any other business and way forward? Dieter and I had intended to have a virtual interim sometime in January or February, and we never got around to getting that scheduled. We do plan to have one, maybe two, between now and the next IETF, which is in San Francisco the week of 17 July. Think about hackathon projects on NTP v5 or Roughtime, because I think that is helpful for us to keep some level of momentum going. And with that, is there any other business? No? All right. Thank you for the folks that joined us at this hour from other time zones.